Today we are going to be talking about functions. Functions. Now, what is a function? In a simple way, a function is a relationship where we put something called the input, and after some transformation, this will give us an output. Now, the weird thing about functions is that, for example, think of it as an ice cream machine, or think of it as some type of machine. You put in P into this machine, right? P goes into this weird machine. The machine does something to P. It follows some rules, and then it transforms it into Q. And this is all a function is. A function takes an input, transforms it, by following some rules, and transforms it into a Q. For example, imagine we have a bunch of outputs, P, Q, R. Of course, these are all the inputs, and they follow some rules. And of course, after these rules have been followed, after these transformations after and a transformation has been applied, they get turned into something else, such as M or N. This should be an N, right? P goes to N, Q goes to M, or R goes to N, and these are the outputs. And of course, this would be a relationship. Now, one of the weird notations, or one of the notations for a function, is known as something as f of x is equal to y, where right here is the input and this is the output. For example, let's say we were to input, I don't know, January, right? Just to see what happens. Let's just see what happens. January, and this gets turned into 3. Or maybe if we put, March, this gets turned into 7. It follows some rule where this is the input, these are the rules, and this is the output. Now, the typical way a function is defined is mostly using algebraic forms. For example, an example of a function would be something as f of x is equal to x squared. Let's do 2x plus 4. F of x could also take the form of 6x squared plus 3x plus 2. This is a quadratic formula. We could have f of x be something like, as we're going to see later on, as some number b to a power x. Or maybe it could be something more as f of x is equal to some number plus 1 squared over 2x. These are all examples of functions. Because again, we could input anything into here, and then following these rules, they will give us some output. For example, let's try the function f of x, and this is the way you read it, f of x. You could also have h of x. You could technically have g of x. You could have any letter in terms of a function. This just tells us what the input is going to be, and this just tells us, the way we could write it. We could write something like z of x. We could write something like z of t, where now instead of using, just using the variable x, we could use the variable t. Or we could write something like b of z, where this is just the formula and this is just the input. And this could be equal to some t. It really depends. So, let's do an example. Let's say that we have f of x, it's equal to x squared plus 3x plus 4. And they're asking us to evaluate, for example, let's do case 1. They're asking us to evaluate f of x as f of x is equal to 2. What do? Well, all the x's get replaced with 2. So then 2 squared plus 3 times 2 plus 4. Well, that's just 4 because 2 squared plus 6 plus 10. And so therefore, this is just equal to 20. What about if we were to evaluate f of x at some value a? Well, now we're going to substitute all the values of a into x. This becomes a squared plus 3a plus 4. Not too bad. Again, we're just substituting n into the function. How about something a little bit more interesting? How about if instead of plugging a single number, we plug in something like a plus h? Well, we will get something, well, all the x's get substituted by that. So a plus h squared plus 3ah, because we're substituting everything, plus 4. Now, ideally, you could simplify this as another quadratic equation. So this becomes ax squared plus 2a8 plus ah plus 3a plus 3h plus 4. You could simplify this. Actually, no, you can't. You could actually just make that. And this essentially would be the function. Let me do another example. Let's do example 2. Let's say that instead of getting f of x, we were given some relation h of p. Of course, this is the input, as we could see already, is equal to some p squared plus 2p. And they asked us to evaluate h of p as some number 4. Well, again, following the exact same thing, all we have to do is just plug it in. H of 4 is equal to 4 squared plus 2 times 4, which is just equal to 16, plus 8, which is just equal to 24. That's it. Now, I want you to try this example. Try example g of m is equal to m minus 4 and evaluate it at g is equal to 5. So give it a go and then we'll walk through it together. Now, it is the exact same process. G of 5 is equal to 5 minus 4, which is just equal to the square root of, 5 minus 4, which is just 1, which is just equal to 1. Now imagine that instead of giving us the input, we were given the output. Essentially the opposite. We are given the result, but we are not given what like the initial condition. But we are still given the rules or the transformation that we have to follow, to transform this input. For example, let's say that instead we were given the function h of p is equal to h of p plus 2p, and we were given the output, which is h of p is equal to 3. What was the initial value? Well, this time we're going to work backwards, and since we know that h of p is just equal to p squared plus 2p, this is really saying that p squared plus 2p is equal to 3. Which implies that, of course, this is just a quadratic formula. So we could rewrite this as p squared plus 2p minus 3p minus 3 is equal to 0. And of course we could solve this by factoring it out. So p squared, so we want some value p, and we want this equal to 3. So ideally we could do plus 3 and negative 1. P squared, 3p, negative p, this becomes 3. This becomes p squared, adding all the common terms, plus 2p minus 3, which works, which means that this is just equal to p plus 3. P minus 1 is equal to 0, which means that p1 is equal to negative 3, and p2 is equal to 1. And these will be the solutions to this problem. We're just working backwards. Okay, and of course we could actually verify this is true by plugging it back in to make sure this is equal to 3. So negative 3 squared plus 2 minus 3 is equal to 3. This becomes 9. This becomes negative 6. And of course this is true. You could also verify that 1 is true, but you could do that. I'll leave that as some tiny exercise for the viewer. Now let's try an example. G of m is equal to 2. Try this one for yourself. Okay, same process. So again, g of m is equal to m, the square root of m minus 4, which implies that m minus 4 is just equal to 2. We could actually square both sides to get rid of that nasty square root, and we have m minus 4 is equal to 4. And of course, if we add 4 to both sides, we get that m is equal to 8. And as you can see, this is the only solution we have. There's no positive or negative solution, which of course we could plug back in, which means that m is equal to 8. So let's plug it back in. G of 8, which is 8 minus 4, which is just equal to the square root of 4, which is just equal to 2. So that works. Now, we could also have cases where we have multiple relationships within another function. An example of this will be something like 2n plus 2p is equal to 12. And ironically, let's say we wanted to express a function of p as f of n if possible. And what this means is that we essentially want to find out what p is with relationship to n. But how do we do this? Well, let me walk through the example first, just to show you and give you a hint. We want to isolate p. This is all the statement is saying. We want to isolate p in terms of n. So let's do it. So we have 2p plus 2n is equal to 12. We're going to move 2n. 2p is equal to 12 minus 2n. And of course, all of these are divisible by 2, which implies that p is equal to 6 minus n. And this is the relationship, because we have p as a function of n. Ideally, we could also do that n is equal to f of p, because again, we want to find what the relationship of n is with respect to p. So we could do the exact same process. So then 2 plus 2p is equal to 12, which implies that 2n 12 minus 2p, and again everything's divisible by 2, which means that n is just equal to 6 minus p. And this is the relationship. This is the relationship. You could have the relationship with how much n is changing with p and how much p is changing with n. It really just depends. Another example of this could be the expression x is equal to y squared plus 1. It's equal to 1, excuse me. And what this looks like, this is the expression for a circle. And of course, we want to express this function, f of x. We want to express, I guess, y in terms of f of x. And I want you to try this example for yourself. Give it a go and see what you get. Okay, so now what we want to do is we want to isolate y in terms of f of x. This implies that we want to isolate y by itself and leave everything in terms of x. So what are we going to do? Well, we're going to have y plus x squared plus is equal to 1. So we're going to move x. We're going to have y is equal to 1 minus x squared. And of course, we're going to take the square root of y. And we're going to take the plus or minus square root of 1 minus x. And this implies that y is equal to plus or minus 1 minus x squared. And what this implies is that we have two solutions. y1, these are all the same function, but they describe a different part. y1 is just equal to 1 minus x squared, and y2 is just equal to negative minus 1x squared. And this y describes the top half of the circle, so this will be right here. And this y describes the bottom part of the circle. Now, overall notes. A function has an input, essentially the stuff that goes in, and then after following some rules and transformations, they will throw out an output. You have some initial condition, whether it's x, y, z, and after following some rules, f of x, or maybe h of y, or maybe t of z, it gets turned into some product that we get, whether it be g, f, or t. You could have functions in terms of many variables, such as x squared plus y squared plus 36 plus 2x plus 3y is equal to 0. And I could ask, hey, I want you to give me this function. I want to see how much y changes with respect to x, which in this case, you would have to move everything to y. Or if I want to find y, I would want to move everything. Or if I want to see how much x changes, I will want to move it to y. And lastly, the other thing is, the way you evaluate functions is by simply plugging in a value. If I am giving an initial condition and I want to see what happens to this initial condition after the transformation, well, let's just put it in and see what happens. Almost like, you have you have some sort of blender, or maybe you have some machine that does something, and you just want to see what happens. Then you just throw something in there. You throw a ball and you might get a shredded ball out, or you might get a unicorn out, or you might get an apple, or you might get the answer to the biggest, answers in life. And in the next section, we are going to be talking about the most notable types of functions and the vertical line test, about what is a function and what is classified as a function.